In November 2016, engineers began pushing a steel arch across the ground in northern Ukraine. It weighed 36,000 tons. It was 108 meters tall. Notre Dame Cathedral would fit inside it with room to spare. They had to move it 327 meters. And they had roughly 40 hours of pushing to get it right. This is the reason it was built 300 meters away from where it needed to be. Reactor 4, Chernobyl. 30 years after the explosion, still lethal. The workers who built this arch carried 2 radiation badges. One told them what they were absorbing right now. The other kept a permanent record of everything they had absorbed in their lifetime. When the second badge filled up, they were sent home, permanently. And the structure they built to protect the world for the next 100 years is now sitting in the middle of a war. Here is how they moved it. April 26, 1986. A safety test at Reactor 4 goes wrong. The explosion lifts a 2,000-ton lid off the reactor core. The fire burns for 10 days. Radioactive material spreads across 3/4 of the European continent. What is left is an open reactor core exposed to the sky. So the Soviet Union builds a box around it, fast. Concrete poured by remote-controlled machines. Steel lifted by helicopter crews who could only work in short rotations before their exposure limits were reached. They finished it in 206 days. Now here is the part almost nobody knows. That structure was never sealed. Sections of it rest on the damaged remains of the reactor building itself, a building that had already partially collapsed. It was rated to last 30 years. By 2010, it was leaking. Rainwater was entering through gaps in the roof. Inside, that water was reaching fuel-containing material. And engineers had a second, worse concern. If the old shelter collapsed, it would raise a cloud of radioactive dust from the reactor hall. Something had to go over the top of it. Something that would outlive everyone who built it. Now, you might be thinking, build a roof over it. How hard can that be? Here is the problem. To build directly above the reactor, workers have to stand above the reactor, and they cannot. Radiation dose is not just about intensity. It is about intensity multiplied by time. Double the hours, double the damage. Every hour a welder spends over that reactor is an hour of a lifetime limit that never resets. So the engineers made a decision that sounds absurd until you understand the arithmetic. They would build the entire structure somewhere else, then move it 300 meters west on clean ground. Radiation levels drop by a factor that turns an impossible job into a merely difficult one. Build it there, slide it here, which creates a new problem. You now have to move the largest structure ever moved on land, across contaminated soil, in one direction, with no easy way back. The arch has to arrive within centimeters of its design position. If it lands wrong, it cannot seal. If it cannot seal, the entire project has failed. So before anything is built, the ground itself becomes the first engineering problem. 2 parallel rails, 490 meters long, have to carry 18,000 tons on each side without settling unevenly. If one rail sinks 2 centimeters more than the other, the arch racks. Steel that is designed to carry load vertically starts carrying it sideways. That is how large structures fail. Watch what they do first. Piles are driven deep into the ground along both rail lines, not to hold the arch up, to hold it level. The soil here is contaminated. Every cubic meter they excavate has to be treated as radioactive waste, cataloged and stored. So they dig as little as possible. Every unnecessary shovel of earth is a cost that lasts a century. The arch itself is not built in Ukraine. The steel segments are fabricated in Italy, then shipped and trucked in. 2,500 kilometers of logistics before assembly even begins. And here is the crazy part. The arch is not lifted into shape. It is built in two halves, and each half is raised from the ground up in layers. They assemble the top section first at ground level. Then they jack it up, build the next section underneath, and jack it up again. The structure grows downward from the sky. Each lift is a moment where thousands of tons hang on hydraulic pressure alone. A single jack losing pressure out of sequence twists the entire frame. The lifting operations are synchronized electronically. Every jack reports its position continuously. If one falls behind the others by more than a few millimeters, the whole system stops. Now the cladding. The arch has two skins, an outer shell and an inner shell, with a ventilated space between them. That gap is not empty. Air is constantly circulated through it and kept slightly drier than the outside air. Why? Because condensation on steel means corrosion, and corrosion means this structure does not reach 100 years. The building has to stay dry inside its own walls. Forever. At peak construction, 1,200 people are working on this site. 27 nationalities. Every one of them carries two dosimeters. The first is electronic. It reads out in real time and alarms if the dose rate spikes. The second is passive. It goes to a laboratory and is added to a permanent record, a number that follows that worker for the rest of their career. In the main assembly area, the dose rate is around 0.0075 millisieverts per hour. For comparison, a dental X-ray is roughly 0.014 millisieverts. So 2 hours on site is about one dental X-ray. That sounds like nothing. And for a day, it is nothing. Now multiply it by a 5-year construction program. This is why the 300-meter decision mattered so much. It was not about making the job easier. It was about how many people would still be healthy in 30 years. And there is a second group of workers most accounts skip entirely. Before the arch could move, the old shelter had to be reinforced, because the arch would eventually have to enclose it without touching it. That work happened close to the reactor, very close. Those crews worked in short rotations, measured in minutes, monitored constantly. One of the hardest constraints in this entire project was not steel. It was the amount of human time available. Money could be raised. More than 40 countries contributed, coordinated through the European Bank for Reconstruction and Development. Steel could be ordered from Italy. But nobody could manufacture more hours of safe human exposure. That was fixed. The engineering had to be designed around a resource that could not be increased. November 2016. The arch is finished. 36,000 tons. 257 meters across, 108 meters tall. And it is in the wrong place. The system that will move it does not use wheels. It uses skidding. 224 hydraulic jacks grip the rails, push the structure forward, release, reset, and grip again. Each stroke moves the arch 60 centimeters. 60 centimeters. 327 meters to cover. That is more than 500 strokes. Every single one has to be synchronized across both rails. If the two sides get out of step, the arch does not slide. It twists. So the movement is deliberately, painfully slow, around 10 meters an hour. A person walking normally covers that in about 8 seconds. Total pushing time, roughly 40 hours, spread across 5 days. Now here is what makes those 40 hours different from any other construction operation. Wind. This arch is a sail. 257 meters of curved surface with nothing to break the wind across open ground. A crosswind during the slide does not just push it sideways, it loads the jacks unevenly. So the operation only proceeds inside a narrow weather window. If wind speed rises above the limit, everything stops where it is. And stopping is not safe either. A partially moved arch sits on rails it was never designed to rest on for extended periods. Every hour of delay increases the exposure of everyone monitoring the operation. Watch the alignment. Survey teams track the arch continuously, not once a day, continuously. Because the correction you can make after 10 meters is trivial. The correction you can make after 300 meters is not. Deviation is caught in millimeters, or it is not caught at all. And as it approaches the reactor, the arch begins passing over the old shelter. The structure engineers have been worried about collapsing for the last 20 years. It cannot touch it, not once. The clearance between the moving arch and the old sarcophagus is measured and remeasured as it advances. November 29th, 2016. The arch reaches its final position. 327 meters, 36,000 tons. Placed over the worst nuclear accident in history without a single contact with the structure beneath it. But arriving is not the same as sealing. The arch now has to be closed at both ends, and this is the part that is genuinely harder than the slide. The end walls have to meet an existing, damaged, irregular building. Nothing about that surface is flat or predictable. Every gap is a path for air, and air moving out of that space carries contamination with it. So the interior is held at slightly lower pressure than the outside. Air leaks inward, never outward. If the seal is imperfect, and it always is somewhere, the pressure difference makes the imperfection harmless. The structure was handed over to Ukraine in 2019. Total project cost, around 2.1 billion euros. Rated for 100 years. And then, 8 years after the slide, history did something the engineers never modeled. February 14th, 2025, 1:50 in the morning. A Russian attack drone strikes the roof of the arch and explodes. The fire that follows does not burn on the surface. It burns inside the cladding, in that ventilated gap between the two skins, for roughly 2 weeks. The waterproof membrane is destroyed. The hermetic seal, the negative pressure system that made every imperfection harmless, is gone. In December, the international inspectors reached their conclusion. The structure has lost its primary safety functions, including confinement, the one thing it was built to do. The steel survived. The function did not. A structure designed for 100 years lost its purpose after 8. Not to corrosion, not to weather, to a war. Right now, engineers from the original consortium, the same companies that designed the arch, are assessing how to repair it. Primary repairs are scheduled to finish by the end of 2026. The bill is estimated at up to €500 million. And one scenario under discussion is almost poetic. To repair the roof properly, workers may need access the structure was never designed to give them. And one option on the table is to slide the arch back, to reverse the most difficult move in construction history. Because the arch was never a solution. It was never meant to be one. Inside it, the reactor is still there. Around 200 tons of fuel-containing material fused with concrete and sand into masses that nobody has yet worked out how to remove. The arch does not fix that. It buys time. A century of working conditions, during which the old sarcophagus can be dismantled from inside by people and machines that do not yet exist. The people who poured concrete in 1986 will never see the end of this. Neither will the people who slid the arch in 2016. The engineers who finish it have not been born yet. That is the scale of the problem Reactor 4 created in a single night. Somewhere out there is a structure even harder to build than this one, and it is already underway. Structures and Stories. Subscribe.